Code please.
Welcome to Code Please. In this channel, I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. In continuity with the previous video, where we created a process with some state that we could ask to manipulate and provide information about, we will see how the Erlang virtual machine and Elixir provide this functionality out of the box in the form of the agent abstraction. The OTP, or Open Telecom Platform, is a set of libraries that ships with Erlang. We can use OTP to build robust, fault-tolerant applications, as it provides a set of useful abstractions to deal with common problems in the programming world. Agents are one of these abstractions. Let's see how we can implement a process that holds a key value store using an agent process. The easiest way to do this is to have the state be explicit and use the agent module directly. I will be running this in Livebook, but you can run the exact same code in Interactive Elixir, or IEX, if you want. Or you can look back at one of my earlier videos and see how you can install Livebook yourself. So let's start by instantiating an agent. And the way we do that is by using the start link function, which returns a tuple OK and the agent PID, process identifier. We'll just call it agent for now. So let's do agent.startLink. And one thing the agent.startLink function requires is an anonymous function where we pass in the initial state of the agent. Since we're doing a key value store, we're just going to pass in an empty map that we will use to store our values in. If I evaluate this, I correctly get returned an OK and PID tuples. Now I can try to return the state of the agent by using the get function. And the first argument is obviously the agent PID that we have. And I can pass an anonymous function where the argument for this function is the state, and this is internally passed in by the agent itself. And then I specify what I want to return to the get function. And I want to return the state, the entire state. So I will just do this. And if I evaluate this, I correctly get an empty map, which is our initial state. Now, if I want to update the state of the agent, I can do Agent.update. And I pass in the agent as the first argument. And again, I pass an anonymous function that takes the current state of the agent. And then I basically manipulate the state how I see fit. And in this case, since our state is a map, I will just do map.put and inside the state, and I will put hello world, which is our go-to kind of thing. And if I end this anonymous function and I execute this, I should get an OK. And then if I do Agent.get again, and I pass in the state, and I return the entire state back, I get hello world because I put hello world in our state. Our process is currently running, our agent is running inside the virtual machine, and we are communicating with it by exchanging messages. And this is kind of hidden from us in the form of the get and update functions. But behind the scenes, our Livebook process is sending a message to the agent process that is running, and it's using receive like we've seen on previous videos, and it's handling all of that. But it's doing it behind the scenes, and it provides this fantastic abstraction for us. If we want to stop our agent, we can just call Agent.stop, and we pass in the agent. And if we evaluate this, we get OK, and our agent is no longer running. So if I try now to do Agent.get, I should get an error saying that the process is no longer alive. Okay, so you might say, yeah, but this way I have to explicitly know what the state looks like and how to manipulate it outside the process. And you would be right. But the cool thing about Elixir is that you can use the agent functionality inside your own module that hides the implementation details of the state. So in order to implement our own key value store that uses an agent behind the scenes, let's define a new module, and let's call it key value. And then we're going to tell it to use agent. And what this will do, the compiler will basically inject a bunch of code inside of here that we don't need to worry about at all. And the only things that we need to implement are basically whatever functions we want to get and update our store, and also the function to start our agent, basically. So we can define a start link function where we accept some options. This is mandatory, but we can just ignore. And we can do Agent.start and start link, sorry, and we pass in our anonymous function with the initial state, which is going to be an empty map, and then end. And we can see that the specific implementation details of the map of the state are hidden inside our module. So whoever calls this key value module has no idea if we are storing the information in a map, if we are storing it in a list, or whatever. So let's define a get function where we accept our store and a key. We're trying to retrieve a key from the store, or the value of a key from the store. And the implementation for this is basically calling Agent.get, where we pass in our store, and we do map.get, where we pass in the first argument and the key. Let's just close this. And interesting fact here, this is another notation. I think I showed this before in another video. If I did not, this is exactly the same as if I would do function state and then map.get state key, and I would end this function. So this is a short syntax for the same thing. It's an anonymous function that takes only one argument and calls map.get with that first argument, which in this case is the state, and then the key as the second argument. So last thing to do is define a way to update our store, and we're just going to create a function named put, where we accept a key and a value, and what we're going to call is basically Agent.update, as we did before, passing in the store. And we're going to do similar to what we did for the get. We're going to do a map.put, where we take the store as our first argument, and this is the first argument of the anonymous function, and then we pass in the key and the value, and this basically updates our store with that particular key value. So if I close all my functions and modules and I evaluate this, I should get some information from the virtual machine saying that the module was indeed evaluated. And now I can do key value. So let's say I do OK, and this is my store, and then I'm going to call key value.start link, and let's just pass in a no args atom as the initial argument, because it's actually not required. So if I evaluate this, I get a key value store started up, and now I can do key value dot get, and I pass in my store. And let's try to say if we have like the hello key in there. We do not, because we have basically an empty state initially. But if I do key value dot put store hello world, and then I run this again, I get the world value, which is the value associated with the hello key inside the state. And if I wanted, just for kicks, I could return the entire state, even though that would kind of mess up the idea of keeping the state isolated inside of my own module. But I could just as easily do def state, for instance, where I get the store, and then I just return basically Agent.get store, and I would just return a function. Well, I could just return this and this, and if I reevaluate this, and now I call key value dot state for the store, I get the entire state back. This way we can get the same functionality, but we don't need to know how or where the key value store saves or retrieves its information. Pretty cool, right? In the next video, we will take a look at yet another OTP abstraction, generic servers, or gen servers for short, which implement the server part of a client-server relation and give us more freedom to define interface functions as we see fit, as opposed to only using update and get as in agents. So until next time, cheers! If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.